I am curious about how the researchers in Antarctica live in the research stations for months or even years. The environment in Antarctica is extremely harsh. Not only is it bitterly cold and stormy, but there are also 6 months of extreme heat. Every year, over a meter of snow accumulates, and the ice can be up to 150 meters thick. The ice shelf drifts 1.5 kilometers toward the ocean annually and can fracture without warning. Traditional architecture cannot survive in such extreme conditions. However, after generations of improvements and upgrades, modern Antarctic research stations are now fully equipped to handle this environment. Halley 6 is the world's first fully relocatable, modular, and enclosed research station, the most advanced of its kind to date. The entire station resembles a row of space trains suspended on the ice, stretching about 190 meters in length and consisting of 8 interconnected pod-like modules. The 7 blue modules serve as living quarters, research labs, and power stations, while the central red module functions as the social hub, housing the kitchen, dining area, bar, gym, media room, and clinic. Each module is equipped with hydraulic legs and large skis at the base. This design allows the station to be elevated above accumulating snow and dragged to a new location in case of dangerous ice movements. The modules are linked by flexible corridors that share electrical and water systems while maintaining independent life support capabilities. Even if a fire or structural breach occurs, each module can sustain the entire team for up to 10 months. So, how does the research team survive? Living here means complete isolation from the outside world, and resupply is extremely difficult. Ships can get trapped in ice, and air transport is severely limited by weather. As a result, supplies are delivered only once a year. One of the most impressive features is its energy system, which is central to daily operations. Halley 6 maximizes fuel efficiency through a combined heat and power system, ensuring no energy goes to waste. Here's how it works. 2 high-performance diesel engines generate electricity for the station. Traditional generators waste a significant amount of heat, but Halley 6 employs a dual heat recovery system. Hot water from the engines flows through a heat exchanger into the heating system, warming the station and providing domestic hot water. The high-temperature exhaust from the engines passes through another heat exchanger, further heating the water. These 2 processes achieve a 60% heat recovery efficiency. After use, the cooled water returns to the engine cycle, forming a closed-loop system. Where does the station's water come from? Halley 6 collects snow in melt tanks using hot water pipes to melt it. The water is then filtered and sterilized for drinking. Although Antarctica holds 90% of the world's fresh water, melting snow is energy intensive, making water conservation critical. The station uses vacuum flush toilets similar to those on airplanes, reducing water usage by 90% compared to conventional toilets. All gray water, from sinks, showers, etc., is recycled, filtered, and reused. Wastewater from toilets is treated in a bioreactor, and residual waste is compacted, frozen, and shipped out during the next supply mission, leaving zero pollution in Antarctica. The interior design is also meticulously planned. LED lighting simulates natural sunlight to combat polar night depression, and color schemes are psychologically optimized to reduce eye strain. This station is not just an engineering marvel in Antarctica, it's also a blueprint for future human habitation in extreme environments.